Hi, this is Amazon, assistant professor, in the Department of Mechatronics and Engineering at the SNS Project Technology. I would like to welcome for the another video session about section of solids. This time we are going to discuss about the project section of solids, especially cone surfaces. So how the cone has been sectioned and how it has been viewed, the truncated prism has been viewed or truncated cone has been viewed. So let's start with the solid software open to for clear understanding, right? So this is the software where I normally used to draw. So as I said earlier, right, we have to draw the cone by center points, right? So I have to draw this by using a 40 die because however large we can able to clearly understand how it has been drawn. So this is how this drawn. Again, I have to draw the in between lines because of cone. It can be visible in all the ways, right? So the trace lines has been drawn. Now I like to mention this as this as in small. This as A, this as B, this as C, this as D, and this will this as D, and this will as O. Now I like to make the trace line from this part to another topmost. Similarly, from every part I have to draw till the reference planes. So I have to draw these things. So these are the trace lines, right? So I make this as in different color for clear understanding. Okay, then axis is height of from a particular point. The axis is height of 70 mm. We can mention this height of 70 mm. So I'm draw this axis. Similarly, I'm going to join this surfaces. Similarly, I'm going to join surface as like the previous thing. So this is an axis line. So I'm giving as an axis line now. So now the color has been changed, right? So I like to give the different colors for clear understanding, right? By using the red color option or some other options. So I'm using this red color option. Okay, now I'm going to section this one with the different ones. So I'm going to section at the 10 mm from length point from is height of 15 mm both the surfaces. So I'm going to draw this from 15 mm. So I'm going to draw the sectional plane passing through this one with an the angle of 65 degree. So now the section plane has to be drawn right down. So similarly, I have to extend this line up. Degree line right now. So I drawn, but this line has to pass this to this. So I am doing it. So I am going to remove this line. So the section plane will be processed this. So the section should be in the dashed line. The section plane has been drawn. Now again, as in the previous video, we have to draw the surfaces right up. So before that, I have to mark this is as A dash. And this will be your O dash. This will be your C dash. This will be your B dash in bracket D dash right up. In bracket D dash. This is how you have to mark it right now. So now this line has to be drawn right. So I can easily mark this one right now. So when I remove this using a term software because of clear understanding right. So when I draw the trace line from this point, from O to C, this is the O to C surface. So similarly, I have to touch till O to C surfaces. So the O to C surfaces represented in different color of yellow, right? Similarly, the line from A to C, right? So the A to C's line surfaces has to be clicked here. So this also to be represented color. Now we cannot be able to predict where O to B and O to D has to be because everything lies under the same thing. So for that, I like to mention this from this point. So I have to take to the revolution surfaces because this is revolution, right? Then again, I have to make this test into till here. So from this point, I can able to understand how it can be revolved, right? So revolving surface is always equal. Now I have to make an arc, right? Tangential arc by arc by center point. So this is center point, and this is a dimension. I like to mark an arc. So now the arc has been marked, right? Now I am using the fill and trim software. I am removing excess lines. So for easily understanding, right? So this is how the marking has to be done, right? Now I like to join the surfaces by different spline curve. So from this point to this point, from this point to this one, and this one to this one, and this one to this one. So now I remove the excess lines. This is where it is. So now I like to fill the surfaces like this one. So it is approximate view where the projection of cone has cutted from particular angle. So after that we have to make the small dimensions like how much distance it has been carried out, and which distance the distance between two lines has to be carried. Distance between these lines is to be carried out 14.2. Similarly, we can able to take the small dimensions like so how the diameter has to be given, what is the height of this has to be mentioned, everything is comes under, right? But this is how the cone section of cone has to be drawn in a particular software for clear understanding of the purposes. Hope everybody is understood the basic concept of projection of solid of especially cone. So thank you for watching this video. I will catch up with in the next video. Till that, bye bye. Signing off by Sambasum, Assistant Professor, SNS College of Technology. Thank you all.